In this video we're going to come up with the equation for this tangent line for this given graph. So we've got our tan graph which looks like this, This tan graph looks like this, and then our job is to find the equation of the tangent line at any given point here. So for example, let me illustrate this in Desmos. So you've got your particle, and then no matter where the particle is, it will draw the tangent line. So our job is to come up with the equation for this tangent line. Okay, so jump back to here. So the equation of this tangent line, well, it's a straight line, so it's going to be of the form y equals mx plus c. Our job is to work out the gradient and the intercept of this straight line here. Well, if you want to know the gradient of something, then you would differentiate it. So we've got to differentiate tan of x. So dy by dx equals, when you differentiate this, it will be 1 over cos squared of x. And if you recognize this, it's actually the same as this, but don't worry if you don't understand this, ignore this. But when you differentiate tan, it will then give you this thing here. Okay, so now this gradient equation, if you like, allows us to work out the gradient anywhere along the tan graph. Anywhere along here we can work out the gradient, but we want to know the gradient right at this point. We want to know the gradient right at this point. Well, we've got the gradient formula. It's 1 over cos squared of x. But if we want to know the gradient right here, we need to put a into the gradient formula, if you like. So the gradient here will actually be 1 over cos squared of a, because you put a into here, because you want to know the gradient at a, so you put a into here. So anyway, the gradient right here is actually 1 over cos squared of a. So our equation so far is mx plus c. We now know the gradient, so we can put this into the m. So that would then become 1 over cos squared of a, and then you've got your x plus c. So this is a fraction. I'm just going to multiply this to the top so it looks neater. So that would then become, hang on, oops, bear with me. So I'm going to multiply it to the top, so that would then become this. So far we are currently here. So now we need to work out the intercept. The intercept is right here. Hang on. So this is our tangent line. The intercept is right here, but we don't know where this here is. We've got to work out this intercept. We've got to work out this c. So once you know m, to work out c, you need one particular point on that tangent line. Well, we know that one particular point. We know this point here. Hang on. We know this point here. We know this location right here. Well, the location right here would be a comma tan a. That's the location right here. So this is your x, this is your y location. So we can put this into the y. We can put that into the y right here. We can put it into the y here, and we know the x location. The x location's right here. It's a, because it's a across and then tan a up. So anyway, this is our x location. We can put that into the x. We can then put that into the x. So that would then become this. Put a into the x, that would be a over cos squared a. And then earlier we would put tan of a into the y. And then plus c. So now it's just a matter of working out c. At the moment you've got 3 blocks. 1, 2, 3. So to get c on its own, just take away this whole complicated block here. So c would be tan a minus a over cos squared a equals c. So now we can put, so our intercept is this whole thing here. We can now put this back into the c. So our equation will now become y equals x over cos squared a plus c. Well, c is this whole complicated thing here, so it would be tan a take away a over cos squared a. So this is the equation of our tangent line. So let's try and show this in Desmos. So hang on. So in Desmos, punch in the tan graph, tan of x. Oops, hang on. Caps lock off. Tan of x. So that's our tan graph. Add our particle. So at any given point, our particle will be at a, comma tan a. Close it off. Well, hang on. A tan a. Close it off. And then add our slider. We want our slider to range from negative 2 pi and positive 2 pi. So now we can slide our particle back and forth. So now it's just the equation of the tangent line. So the equation of the tangent line was x over cos. Hang on, I can't remember. Hang on. So this is the equation of our tangent line. It's x over cos squared a. So x over cos squared a. And then our intercept was tan a minus that thing there. So our intercept was plus tan a minus what? Minus a cos squared a cos squared a. So that's our tangent line. So now as you move the particle, it will calculate the gradient at that particular point, and it will work out the intercept. From that, it will draw the tangent line. Okay.